we want to find the pressure on this door in this this dam here. Okay, so what we want to do is add up the pressure, okay, at each layer. So let's say that's one layer. Of course, this layer is different width as we go to the top and to the bottom. Okay, let's start with the fact that force is pressure times area. Pressure is density, gravity, depth, area. Okay, so let's say this up here. Okay, so this is 0, and we go down to, okay, this is 0, and we go down all the way to the depth of 10, right? The difference between 2 and 12. And let's let this be x. So go down all the way here. From here to here is some x star. Okay. So for instance, one strip of hydrostatic force is, this is going to be 1,000 G, right? X star times by area, which is the width, times by delta x. Okay, let me just draw this semicircle here. So this is 2, that means the radius is 2. This is a circle with x squared, with the equation being x squared plus y squared is equal to 2 squared, which is 4. So the width here, right, the width is clearly just 2x of this equation. Okay, and x is going to be 4 minus y squared, square rooted. Okay, and okay, so for example, that right there, let me just color it exactly the same. Let's say that point there is xy. This y here, which represents that length. Okay, so represents that length, which is that length right there. That's the difference between, do you say it's the difference between 10 and the length x? Okay, so that's, okay, let me actually replace here. This is half of w, and y is, right, 10 minus this x star, okay? This minus x star. Of course, 2w will be just, you know, you multiply both sides by 2. Okay, and delta x. So this tells us, this is a setup for one strip. The total hydrostatic force is going to be integration from the depth of 12 minus 2, which is 10. Sorry, not 12. This is 10, right? 10. So 10 minus 2 is 8 to 10. 8 to 10 of this. And I forgot the square there. dx. That's the setup. Okay, I'm gonna let this right here be, actually let's do some substitution first. This is another case of integration by trig substitution. Okay, so let's let, so difference 10 minus x equal to sine of theta. So you get minus dx then is equal to cosine of theta d theta. Okay, let's make the substitutions now. I'm not going to write the 8 and 10 as I simplify the integral. So we're going to get, oh, sorry, I have to put, I'm missing a value here. Right, I have to put 2 to compensate for the fact that this is a 2 squared. Okay, so x will be 10 minus 2 sine of theta. Okay, that x. And we get 4 minus, if you square this, you get 4 sine squared theta. And the dx we can replace with a minus 2 cosine of theta d theta. Okay, this right here will simplify to a 2 cosine of theta, because this to be factored out of 4, you get 1 minus sine squared theta, that's cosine squared theta. Square root the cosine squared theta, and you get that. Okay, so we have that. I'm going to factor out a minus 2 from there to get sine of theta minus 5. Okay, so we have minus plus, that's plus 8. So we're going to get 8,000 G factored out. That's factored out. Okay, how do we integrate this? Okay, let's expand this. So you get 2 integral. Okay. I just expanded that, right? This times by this times by this. Okay. I'm just gonna let that be k, okay? So I don't wanna write that every time. Well, I'll simplify this. So this is k, and here you can let v equal to cosine theta. Then you get dv is equal to minus sine of theta d theta. So I have sine of theta d theta, so this is going to be integral of minus, right, minus v squared dv. And that right there is the integral of cosine of 2 theta plus 1 over 2 using the double angle formula. Okay. Okay, let's continue. So now we have a minus v cubed over 3, 5 over 2. Okay, if you integrate this, it's going to be half of sine of 2 theta and just theta. Now I'm going to change this all back to x. Okay, so first of all, that right there I can replace with cosine. That's cosine theta. Now, going back to initial substitution right here. Okay, let me just do this in different color. Sine of theta is equal to then 10 minus x over 2. So that forms this triangle here. This is theta, this is 10 minus x, and this is 2. And this is, by Pythagorean theorem, 4, this square minus that squared. Okay, and furthermore, this thing here is equal to, okay, so that'll simplify to half times by this is just sine of theta, cosine of theta. Okay, so cosine is just that over this. So we have 4 minus, okay, the square root of 4 minus over 3 over, sorry, this is over 2 cube that and over 3. Okay, that cube over 3. Sine of theta is that. Cosine of theta, of course, is that again. And theta is just sine inverse of 10 minus x over 2. Okay, this should be a square bracket. And now we're going to plug in 8 to 10. Okay, let's continue here. Okay, if we plug in 10, note that this turns into 0. Right, so we just get root 4 over 2, which is 1. Cube is 1. So that's 1 over 3. If you put 10 in here, that turns into 0. So 0 times anything is 0. Again, that's 0, 2. So this is all gone. Minus, now we're plugging in 8. Okay, so in here, if you plug in 8, okay, 10 minus 8 is 2. 2 squared, again, this is turns into 0. This is 2 over 2. This again turns into 0. This is sine inverse of 10 minus 8 is 2. 2 over 2 is 1. Well, that simplified a lot very, very quickly. Right, so k, right, this is gone. So we really just have minus 5 over 2, but there's another negative, so positive 5 over 2 sine of 1. Okay, so sine inverse is equal to 1 at pi over 2. So k was equal to 8,000 g. 8,000 times by 9.8. This is 5 pi over 4 minus 1/3. Okay, and that's what I get.